think of myself as a coder, and I don't think this is the appropriate word to describe my profession, and I suppose that many of you agree with me, so I would like to rename this talk as to what I want from a programming tool, but this has an unfortunate side effect, that it awakens a philosopher that sleeps in my heart and makes me ask the question, what is programming? So the obvious answer is that programming is whatever programmers do. So apparently it's putting cables into appropriate slots, and as I can see from your faces, you're not quite agreeing with this. But that's probably because you're already after the personal computing revolution. So here we have a personal computer, and apparently we can see that programming is about switching switches and pressing buttons. And I think that this still doesn't cover the programming experience that we have. So it is pressing buttons and punching holes, which, well, still not quite there yet. Here's what we are all probably more comfortable with. So it's typing text and getting responses from the computer. But as I think we agree, programming wasn't about switching switches or plugging cables. It is also not about typing text. So what is it about? So the one thing that's been common in all these examples were computers. So is programming about making computers do things? And I will give you a counterexample in honestly the prettiest programming language I have ever seen. And this programming language is not for programming computers, but for programming people. Are you ready? Okay, so this is clearly a program. It is made for programming people, and it is real programming, which you can see here, that it contains this import util statement. Okay, and actually, so this has been inspiring to people, so you can find online algorithms expressed in this way, but they have one problem, namely you cannot execute them, at least in this form, and this is what we are going to try to fix today. Okay, so I've been thinking about it, and I don't really know what programming is, but I know that at least it is an intellectual activity which somewhat involves modeling. And I don't know why we are sticking to text so much, maybe because it's convenient to write notes in text. But if we turn to authorities, we will see that they claim that programming is, or at least it should be, fun. So my girlfriend took me once to a concert, and as you can plainly see, I was having fun. I was working on this project that I will be telling you a bit more about. So the idea here is to be able to write programs not only in text, but in non-text as well. And we'll get back to this, but there was a problem. Namely, I broke my laptop, so I couldn't do this work anymore. But I had a solution, and it was right in my pocket, and it's probably in the pockets of all of you. And it's called, so Steve Jobs gave this specification to his engineers. I want a single piece of glass that I can use to read email on the toilet. And it turns out that there are so many more interesting things that you can do on the toilet. And this is not a toilet. This is a train. But these are. I got this Bluetooth keyboard at a store with Chinese stuff. It was really cheap, and these are my work conditions when I'm lucky to get a sitting place near the window on a train, because I commute from work. I spend approximately an hour a day on a train, so that's just good time for programming. So if I'm slightly less fortunate, I can use the bike phone handler to attach my phone to a pipe on the train, but usually that's not the case. More often I have to stand on the train, and so this is also a cover of a heater in a train, and this is not a coincidence, I think. I started fiddling with this thing. So what could I do program without a keyboard or with limited support for keyboard, and I came up with this. I gave this demo a couple of times. So this is an interpreter of Lisp. It is tactile, and you can evaluate expressions. So I don't know. You can, for example, use it to compute powers of 2, which is fun. It really is. And you can also define your own functions. And I'm getting terribly good at this recently. So I'll just define the factorial functions for you. So the factorial of n, we define it in the following way. If there is a smaller than or equal relation between n and 1, 1, then we return 1. Otherwise, we return the product of n and factorial, but not of n, but of, n minus 1. And does it look good? Yeah. No, not really. It's too stretched. So what can we do? We can grab the left parentheses and shake the phone. And now we can evaluate it. So if I'll make a copy of it, I can, for example, compute the factorial of 5, which is fun, but I can also compute the factorial of 120, which is more fun. So one thing that it cannot do is it cannot do these non-textual things. And as I was developing it, I had this problem that I sort of hit the wall, and besides it was written in Java, and this was very, very sad for me. So I dropped this project. I'm sorry. Okay. So this, I'm sure some of you at least are familiar with this idea. This Leif Anderson calls this interactive visual syntax. Who hasn't seen this? There's a couple of hands. So after I don't know, maybe tonight, you can go to Google and type interactive visual syntax and watch the movie. It's brilliant. Okay, so actually I didn't drop my work on Grasp. I just started from scratch this time, developing it in Kava scheme, which is a dialect of scheme that compiles to JVM bytecode. And, sorry, I think I have to show. And, okay. And as you can see, when you open it up, it shows some help information that's completely irrelevant, but more, so I can still evaluate expressions. But more interestingly, I have this, at least some partial support for this interactive visual syntax thingy. So this thing here is what I call visual stepper, unsurprisingly, I hope. Maybe. And I have to say that, calculating the factorial function probably isn't the most interesting example in the world. So this is a conference related to the future of coding, and what I'm showing you is the past of coding, or at best it is the present of coding, because it already is. So now I'm going to show you the scrappiest of the fiddles, namely how I imagine you could encode the A* search algorithm. So I have a close-up here. So we can define a function called optimal path on graph from start until success, guided by some estimate. And here on the right, there are type signatures. So we know that success is something that takes a node and returns a Boolean, and so forth. And in order to do that, we define a helper function called explore paths, avoiding visited nodes, where paths are, of course, list of path, and visited nodes are a set of node. And the body of the function is the invocation of this helper function on a path that has some, to which we provided an estimate and some initial value of 0, because start has 0 cost, and it hopefully will get some time to the goal. And we want to avoid the starting node again, because if we had a cycle, it would surely be more costly. And the body of this explore function, it pattern matches. So if the list of paths is empty, then we return nothing and plus infinity. And otherwise, if it is a path that ends with some tip and has some total cost, then and the tip reaches the goal, so it satisfies the success predicate, then we will return the value of start ... tip. So we'll return this path along with the total cost. And here's the most complex third case. So if we haven't reached the goal yet, so it's still in front of us, then we pattern match on this, and we have some estimated total cost and some cost so far. So this is the first path in our list. We pattern match on it. We could pattern match on it in this way, and then we apply the neighbor functions to the tip to get the list of neighbors, and things like this. So, what would we need to have in order for this to work? So, the first thing is we need to have a type called step, which contains 2 fields: a cost, which is some non-negative number, and a target, which is a node that we are going to walk to. So this is a single step, and the cost on those single step when we're walking on a graph. And this is how we would want this to render in the editor. And likewise, if we have a path, we would like it, so it has 3 fields: step, cost so far, estimated total cost. And we would like it to render in this following way. So we have this Carly over brace, Carly under brace, and the list of steps, and this funny image here. And I don't know how to do that. I mean, I have some ideas how to get there, but also here's an actual program that we could write, and this is the merge operation. The merge operation known from the merge sort. So it takes, it is called, I mean, traditionally it's been called merge, but I call it open square bracket ... short rectangle, tall rectangle, ... close small bracket, square, and sort of vertical arrow, and the square is trying to jump in the middle of this thing here, which I think it's quite a good name. And as it suggests, it takes 3 arguments. It takes the argument called square ... small rectangle, tall rectangle, ... close bracket, the black rectangle, and this arrow. And we pattern match on this first argument that henceforth I'm not going to pronounce it. And if it is an empty list, we return a list containing of a single element, this element that we passed here. Otherwise, if it is a non-empty list, then we destructure this list into the first element that will be called the white rectangle, and the rest of the list that will be called ... and if we apply this function, so this tallness of the rectangle, and if it is smaller than the tallness of the white rectangle, then we just return a list where we added this rectangle, this black rectangle in the front of the list. And otherwise, we form a list whose first element is the white square, and whose remaining elements are the recursive invocation of the function itself. So I think it's all clear, is it? Cool. And now I want to show you some other aspect of the editor that I made. So one advantage of having this sort of canvasy thing is that you can zoom it out. And as you can see, as your program grows, it's getting taller and taller. And so what does it remind you of? Or what would be the right medium for storing this kind of thing? And I will give you a hint. And I think that this actually explains a lot about the quality of the contemporary software. What we could have instead, is that when we zoom out, when it gets sort of unreadable, then it could turn into sort of abstract from the module. So I could just have only the symbols that are exported in this module and their types, for example. And that would be neat. And I don't have that because that's future of coding. And if we zoom out even further, we could see, so maybe there was this talk that probably very few of you have seen, right? It's called Rethinking Visual Programming. It's been given at a Go-related conference, so no wonder. And so the author, I mean, it's a really good talk, and I recommend watching it. The author gave a great metaphor. So he explains that the IDE is like a torch in a cave, and you use it to read the cave paintings. And he also made a prototype, and this I think is quite unfortunate because it's a 3D structure, and what we would like to have instead would be a map, because when we have a map we can say where is north, where is south. We could, for example, we can actually use our spatial intuition to navigate around code, which is something that we cannot do now. Okay, and this is actually how the programs look like. So I stole this slide from Andy Wingo from his Scheme Workshop slide, but these are the structure. This is the structure or dependencies of modules in Guile. So they form sort of a layered graph, and maybe this doesn't look particularly compelling, but it would look much more valuable if it was interactive, and if we could tell how large the specific modules are. Okay, so here's the recap. So I want my code editor to be pleasant to use on the phone, support interactive syntax, provide abstract view and a module browser, please. Thank you.
I look forward to screenshots from your slide being used in other presentations. One quick question. Let's just say applause for Premium Trolling. That was amazing. Thank you.